Hello friends, in last class we have seen what is a process, what is a thread, what is a single process thread, single threaded process and multi-threaded process. In a process, if there is only one thread, then it is a single threaded process. In a process, if there are multiple number of threads, then it is a multi-threaded process. And also we have seen the benefits of multi-thread programming. Okay, so now we will move to second topic, that is multi-threading models. So here its name itself is a multi-thread. It means that in a process there are multiple number of threads are there. So how these threads are organized or structured, those are nothing but models. So this topic is multi-threading models. Before going to models, we will see the how we can support these threads. Usually threads will be supported in two levels. One is user level and kernel level. The threads which are present in user level and they are supported by users, not by the operating system or kernel, they are called as user threads. And the threads which are present in kernel and which are supported and managed by the kernel directly or operate directly by the operating system are called as kernel threads. If you go back and recall the first module and the first diagram, that is components of computer system. Basic component was hardware, then operating system, then system programs and application programs, then some set of users were there. So in between operating system and users there are many number of system programs and application programs are there. So this kernel threads are present in operating systems and user threads are present in user level. So the threads which are supported and managed by the users will be called as user threads, and there will be no any interference or intervention of kernel. But in kernel threads are supported by supported and managed by directly by the kernel or operating system. There will be no any intervention or interference of users. So there must be one some relationship between user level threads and kernel level threads. There are three types of relationships are there. One is a many to one relationship, second one is one to one relationship, third one is many to many relationship. In many to one relationship, by observing this diagram you can easily understand this relationship. There are many number of user threads are there, but there is only one kernel thread is there. So this model maps many number of user threads to one kernel thread, and here thread management will be done by thread library. It means that the library is nothing but a set of threads. Because of that only it is called as thread library. And since there is only one thread which can access or use kernel at a time, this multiple threads are unable to run in parallel on multiprocessors. You just recall our benefits of multi-thread programming. Their fourth benefit was there, that is utilization of multi-processor architectures. Even though there are many number of CPUs are there, if our process is a single threaded process, it can run only on only one CPU. Even though there may be many number of CPUs, those are all other CPUs will be idle. So instead of that one we can use multiprocessor or multi-CPU systems, multiprocessor architectures, so that all threads can run parallelly or concurrently. So here green threads will adopt this model. That green threads is nothing but it is a thread library which is present in Solaris operating system. Yeah. Then second relationship is one-to-one model. So as diagram shows here, there are n number of user threads are there and the same number of kernel threads are there. So in this model maps each and every user thread to a kernel thread. And also, since there are equal number of user threads and kernel threads, it provides more amount of concurrency or parallelism comparative to many to one model. So by allowing this all other threads also to run in a same time, it also allows multiple threads to run in a parallel on multiprocessors. So this is a benefit of our multi-thread programming, right? So that fourth benefit was utilization of multiprocessor architecture. Okay? And the only drawback of this model is, so since there are n number of user threads are there, that same number of kernel threads we have to create here. So if our processor is busy in creation of these kernel threads only, then it will the performance of that application or processor will be reduced. So because of this reason, most implementation of this model will put on a restriction on this number of threads. Okay. Then Linux and Windows operating systems have implemented this one-to-one model. Okay. Then many to many model or many to many relationship. Here n number of user threads are there, and lesser number of kernel threads may be present, or else same number of kernel threads may be present here. Because of that only it is called as many to many model. So if there are n number of user threads are there, at the kernel level also there may be n number of or equal number of kernel threads, or else lesser number of kernel threads may be present. In this model maps or multiplexes many user threads to a small or equal number of kernel threads. Here then how many number of kernel threads may be present there at a kernel level? This number of kernel threads completely depends on particular application or particular machine. Based on the type of machine or type of application, these number of kernel threads depends here. And many to one model allows a developer to create many user threads as he wishes. Parallelly, complete concurrency or true concurrency or parallelism can be achieved, because the kernel can allow only one thread to be executed at a time. Okay. Since one-to-one model allows for a greater concurrency, it means higher parallelism, the developer has to be very careful, and he has to take care of not to create too many number of threads, because if he creates too many number of user threads, then he has to create that many number of kernel threads. Okay. The many to many model will not suffer or will not face some drawbacks or defects which we have found in one to one model and many to one model. What are those defects? We will see here. First, in one to one model, developers can create as many number of as many user threads as necessary. If they create many number of user threads, then that user has to create same number of kernel threads also, and those kernel threads can run in parallel on multiprocessor. But in many to many, what happens in many to many model, there is no need to create the same number of kernel threads, because already there are equal or lesser number of kernel threads are available. Okay. Then the second drawback of these previous models are second drawback is that is a drawback of many to one model. In many to one model, what happened when a thread performs any blocking system call? It means that if a thread wants to be blocked or terminated, then that kernel can schedule another thread for execution, because there are many number of user threads are there, but there is only one kernel thread was there in a many to one model. But in a many to many model, what happens when a thread performs a blocking system call, the kernel thread also blocks, but still that application continues to run, because there are still many other kernel threads are running. So next, there is one more version or variation of this many to many model is there. That model is called as a two-level model. So even though there are equal number of kernel threads or lesser number of kernel threads, each and every user thread tries to be paired with the respective or corresponding kernel thread. That is the through two-level model. It means that there is a 100% assurance is there. A user thread will get one kernel thread. So that is one popular variation or version of this many-to-many model maps or multiplexes many user level threads to smaller or equal number of kernel threads, and also it allows a user level thread to be bound or paired with the kernel thread. It means each user thread gets one corresponding or respective kernel thread here. So this variation or version is called as two-level model, and it is supported by some operating systems like IR, IX, HP UX and True64 Unix family operating system. Thank you. In next class we will move to thread libraries. Thank you.